All right, so find the domain and range of the following function. So that's the a problem in I mean regarding the 4.1, not 4.2. So you see that this is exponential function, right? So using the transformation, we can plot the graph of the f of x, and then we can figure out domain range. Okay, so see. All right, so f of x, this is problem number 4.2, problem number 15. Okay, so f of x is defined by negative 1/2, and then 3 to the x minus 6, okay, plus 6. All right, so we're going to start from the a function defined by 3 to the x. Okay, so the 3, that's the base, right? So if a base is greater than 1, then the graph of g of x is going to be like this increase function. Okay, so this is graph of g of x, and then this is y-axis, x-axis, and the y-axis must be 0, 1. I told you when I cover 3.1, for any choice of base a, well, the y-intercept of exponential function must be 0, 1 always. Okay, I told you. So keep in mind that. Now then what? We need to get the x minus 6, right? Okay, so I'll just replace x by x minus 6. That's the horizontal translation, right? Okay, so keep in mind that. So g of x, so now see, we can apply the ht. Okay, so now the g of x minus 6, this is what? Shifting the graph of g of x to the right 6 unit, right? So right 6 unit. Okay, so g of x minus 6, that's going to be 3 to the x minus 6. Okay, so graph move to the right 6 unit. Okay, and then we're going to get like this. I mean, the y-intercept to figure out the graph of g of x minus 6 a little bit more clearly. Let's figure out what happened to that point. This y-intercept 0, 1 is moved to the right 6 unit. Then the point going to be right here, and then this is going to be 6, 1, right? Okay. So the graph of g of x minus 6 must pass that point. Okay. And then graph must be like this. Okay. So can you see this? Let me use other color. Let's see. Okay, can you see that, right? So this is graph of g of x minus 6. Now then, we're gonna what? You see that now next is, remember that the order of transformation, the ht, stretching or shrinking or reflection, and then vt, right? So you see negative 1/2. That's a, see 1/2, that's a shrinking, right? So by a factor of 6. A factor of 1/2, right? Sorry. Okay. So that's going to be 1/2 times g of x minus 6, which is 1/2 times 3 to the x minus 6. So the shrinking means that what? The y, for the same the x coordinate, their corresponding y coordinate will be shrinked by a factor of 1/2. So that point 6, 1 will be transformed by 6, 1 times 1/2, which is 6, 1/2. So right here. Okay. All right. So not only that point, but every single point on the graph of g of x minus 6. Okay, every single point, their the y coordinate will be shrinked by 1/2. So The graph must be like this, like that. Okay, but keep in mind this: the still the graph 1/2 times g of x minus 6 will never touch x-axis. Okay, so it's really touch, but you know, actually it's not. Okay, keep in mind this. So now next one. Ooh, let's see. Next one is what? Negative, right? So the multiply what? The function by negative sign, that's the reflection about the x-axis. Okay, so negative 1/2 times g of x minus 6. That's gonna be what? Oh, it should be, sorry, this is the reflection. X-axis. Okay, it's gonna be negative 1/2 g of x minus 6, which is negative 1/2 times 3 to the x minus 6 power. Okay, so let me reflect this one about the x-axis, then we're gonna get this, right? So that's the graph of negative 1/2 g of x minus 6. Okay, then what happened to graph? Just reflecting this one about the x-axis, then we got 6 comma negative 1/2, right? And now last one, adding 6, that's the vertical translation. Okay, so now vertical translation, so upward 6 unit, right? So it's gonna be negative 1/2 g of x minus 6 and the plus 6. Okay, so that's gonna be negative 1/2 3 to the x minus 6 plus 6. Okay, so this is exactly the same as what? Definition of f of x, right? Okay, so this is equal to f of x, by the way. So let me shift the graph, the blue one, to upward to 6 unit. Then you see that point will be moved up 6 comma negative 1/2. Just shift to the upward 6 unit. Then we're gonna get what? 6 minus 1/2 right here, which is what? 6 minus 1/2, which is gonna be 11 over 2, right? Okay, so here, so this is gonna be 6 comma 11 over 2. Okay, all right. So graph must be like that. Okay, so this is gonna be, so this is gonna be a negative what? 1/2 g of x minus 6. Okay, and then plus 6. Okay. Okay. So now, well, that's not the goal, right? So in this problem, we want to find out domain range, right? So as you can see, that range is going to be negative infinity to infinity because the graph, um, I mean, sorry, domain is going to be negative infinity to infinity because the graph just goes down as x approaches infinity, and then as x approaches negative infinity, still we can figure there exists y value corresponding to x value. Okay. So because the graph doesn't end right here. Okay, just keep going to left hand side, right hand side. But the thing is this, the range. To figure out range, you need to understand the new terminology, asymptote. Okay, what's the asymptote? Asymptote is the straight line, could be vertical line or horizontal line or a slant line. Okay, is a straight line the such that the graph of function approach. Okay, so this is the straight line. Maybe multiple. There it could have multiple straight line. Okay, is such that s dot t dot means such that. Okay, see the graph of f of x. Graph of just a function. Okay, graph of a function. a function is approaching. As x approach infinity, or negative infinity. Okay. Okay, man. I know it looks maybe it's hard. Maybe probably it's hard to understand this. So I'll show you example. So example is this. Think about the any I mean just basic exponential function. Okay. So f of x is equal to 2 to the x power. Okay. So then graph of the exponential function is like this, right? Then look at this part. As x approach negative infinity, it means x is getting smaller and smaller. The graph approach x-axis, right? So in this exponential function, f of x has horizontal asymptote, which is x-axis. So now x-axis is the what? Asymptote of function f of x. Okay, we can say that. Okay. So, but actually not only 2 to the x, but for any choice of base a, their asymptote must be x-axis, right? Because, the not only, 2 to the x, but 3 to the x and 4 to the x, the graph must be like this. And then as x is getting smaller and smaller, the graph will just approach x-axis, right? Also, if the base a is between 0 and 1, for example, let's say g of x is 1/3 to the x power. So the base is between 0 and 1. The graph of this guy is like this. Right, see? So as in this case, as x is getting bigger and bigger, I'm approaching infinity, the g of x approach x-axis, but never touch. So that what this guy g of x has the asymptote x which is x-axis. Okay. So then what about the log function? So last time we learned the graph of log function, right? So this one, okay, that's going to be say f of x, say log of x to the base a. Okay, here a is greater than 1. Okay, give me a second. It's greater than 1. Okay, so in this case, that log function, as x approaches 0, okay, the graph just approach y-axis. So this f of x has what? Y-axis, vertical asymptote. Okay, vertical asymptote, which is y-axis. Okay, so now then, what about the other one? Let's say g of x is log of x to the base a here. What about a is between 0 and 1? Okay, then the graph of this guy is like that, right? Okay, right here. This one is x approach infinity, approach 0. The graph approach y-axis too. So this guy has a vertical asymptote, which is y-axis. Okay. So now we understand. I hope you understood asymptote. So now back to the here. And then the what? When you take a look at this blue curve, the blue curve approach x-axis. So asymptote of this function is x-axis. But once you move the graph to the up or 6 unit, okay, then there is a line. Excuse me. So there is a line such that the red curve approach, right? So then what is this? What's the equation of that horizontal line? That's going to be what? Y equals 6. Because just this is nothing but what? The x-axis is shifted upward 6 unit. Okay, just think about this. When you shift the blue curve upward 6 unit, you can shift the asymptote of that curve upward 6 unit too. So y equals 6, that's going to be asymptote, horizontal asymptote of the function f of x. Excuse me. So now domain range is going to be what? negative infinity to that 6, but 6 is not included. Okay, so why the range is going to be negative starting from negative infinity? Because as you can see that the red curve is just going down as x approaches infinity, right? X is getting bigger and bigger, the graphic is just going down more and more. So the range is going to be negative infinity to 6, but open interval 6. Okay, so here the answer is, now in this problem, the domain is going to be negative infinity, infinity. Okay, the range is going to be negative infinity to 6 open. Okay, keep in mind this. Okay, so and the key in mind is the concept of asymptote. Okay, so now we move to the next problem. See. All right, so the problem 15, yeah, problem 15, we just solved it. This is really good problem, okay? You may see that kind of problem in exam 3 and final exam, okay? So keep in mind that. And then problem 14, so here's a question. Find the approximate solution to the following equation. So 6 times e to the x equals 5. So what is e? E is the natural number, and irrational number, e natural number, but e is an irrational number, 2.718, and then something. Let's keep going. Okay. So and then you should know the natural log too. Last time I told you I introduced uh, the um, to the log often used, okay, in science. What's the common log and natural log? Common log is log with base 10. Then we don't write the base 10, okay? And then natural log is log with base e. Instead of the symbol log, we use ln, okay? So keep in mind this. So now what are you gonna do? Yeah, we solve the problems, okay? So it's not that's not the polynomial equation. So we have to use log, either log or, I mean, one-term property of exponential function or one-term property of log uh, logarithm, okay? So 6 times e to the x is equal to 5. So now, to solve it, what does that mean, solving the equation? Solving the equation means they isolate x, right? So how can I isolate x? Because now we cannot isolate x because x is in the exponent. So somehow we have to pull it down out of the exponent, that position. So to do that, we're gonna the isolate exponential term. Okay, you see the e to the x? This is exponential term, right? So I'm gonna just multiply by 1/6 to make this guy to 1 so that we can isolate e to the x. Then we're gonna get this, e to the x is equal to 5/6. And then we take a natural log, okay? Then let ln e to the x is equal to ln 5/6, okay? So now this is kind of, you see, this method 1 and the method 2. I'm gonna solve the two different way, okay? The first one I'm gonna use using the one-to-one property of log. One-to-one property log is what? Log of x1 to the base a is equal to log of x2 to the base a. If you got two log expressions are equal, okay, then, or you can say if and only if x1 is equal to x2, okay? So see that e to the x equals 5/6. It means that then by the one-to-one property, the log of e to the x is equal to log of 5/6. But specifically, I choose the natural number e as a base. Okay, why? Because once you choose the e as a base, then the what x, now this is exponent, can be brought out in front of natural log, and then so x times the natural log e, and the natural log e must be 1. Okay, so the right hand side is 5/6 by the laws of exponent, laws of logarithm. Okay, so let me tell you again, 3, 4, Yeah, one. Yeah, so there are more than four, but just four laws of logarithm. Okay, so law one, law two, law three. Okay, law four. Okay, there are more than that. Okay, but I think in this class normally we use the four laws. Okay, of logarithm. Okay, so the first one is log of a to the nth power to the base b is equal to n times log of a to the base b. This, by the way, four laws is really important. You should memorize it. Okay. Then law two is excuse me. So log of a to the base a is equal to 1, and then log of what? 1 to the base a is equal to 0. Last one, log of a to the base b is equal to log of a to the base c over log of a to the base b, b to the base c. Okay. Sometimes law 4 is useful because that's the way to change base b to c. Okay. So keep in mind this. You see that why the natural log e to the x is equal to x becomes x times natural log e because of law 1. Okay, you see that, and the exponent of that number can be brought out in front of log right here. Okay, the y natural log e is 1 because log of a to the base a equals 1. Okay, so if you forget about the natural log, is what? Log of the base e is called the natural log, and then this is denoted by ln a. Okay, denoted by the symbol. This is denoted by. Okay, so back to here. Now then, we got this. X is equal to natural log 5 over 6. Okay, still you don't get it maybe because natural log 5 over 6 it looks like a complex abstract, but actually this is a number. How can you figure out that? Just let me use a calculator. So here, so you see the natural log right there. I mean, not only just TI series calculator, but also normally there is that ln button. Okay, so LOG is a common log, which means the log with the base 10. ln dash natural log with the base e. So I put the ln and the 5 over 6. We got the negative 0.18232, but the problem says that write to 4 decimal places as needed. So we got the negative 0.1823. Okay, so approximately negative 0.1823. Okay, that's the answer. Okay, so what about the second method? Without using the natural log things, I'm gonna figure out equivalent. Let me see. Equivalent log expression of exponential expression. Okay, so I told you there are two interpretation of log. The first one, in a view of function, the log function is inverse function of exponential function. That's the first interpretation of log. The second one is this: the log is what? Log represent exponent of the exponential function. Okay, associate. Okay, so now you see the x right here. Actually, x is equal to what? Log of 5 over 6 to the base e. Okay, so let me tell you again here. Oh, so let's say y is equal to a to the x. Then this one is equivalent to this. X is equal to log of log of y to the base a. Okay, so we could the forgiven exponential expression, the exponent can be expressed in terms of log, symbol log. Okay, right? That's why I told you log represent the exponent of the exponential function, exponential expression associated. Okay, so now then back to these problems. So this is what? This is ln 5 over 6, right? Because base is e, we can use ln, right? Okay, so this is more easier than this one, but you have to know both, because when you solve the more complicated equation, definitely you need to use these laws. Okay, keep in mind this. Okay, yeah. So now I'm going to move to the next problems. So excuse me. Let's see. So next one is a 10. See, solve the this 10 to the x power is equal to 18. So you see, this is similar to the the problem number 14, right? So let me see. So let me just use solve the problem using the second method. Okay. So this is problem number 13. So 10 to the x is equal to 18. Okay. So now then x is equal to what? This is equivalent to what? X is equal to the log of 18 to the base 10. Okay, this is common log, right? So log 18, you can just write log 18, which means a common log. So the calculator, this I'll use a log, okay, and then 18. So the answer is 1.2552, okay? So round to 4 decimal places. So we got 1.2553, right? So 1.2553, okay. All right, so now next one, let's see. Uh, let's see. Okay. So let me see problem number 11. Okay. So find the inverse function. Yeah. Find the inverse f inverse of x. Okay. Of f of x defined by 9 to the x power. Okay. But let me tweak the problem a little bit more complicated. Okay. So 9 to the x power plus maybe um, -2, something like that. Okay. And then let me see. Let me put 1/2 right here. Okay. So sorry, it's a little bit messy, right? So let me rewrite. Okay, f of x is 1/2, then times 9 to the x power -2. Let me 3. Okay, let me 3. Sorry. Okay. So I want to find out the inverse function of this. A similar problem should be in the the textbook. I think example the 11 in chapter 4, section 4.2. Okay, so if you have time, just look at it. So by the way, I just tweaked the problems. Okay. So to find out inverse function of this one, you see that this is the exponential function, right? So then we know that what inverse function of that function must be log function, right? So anyway, so I'm going to use switch and solve method. Okay, what's the switch and solve method? It consists of 5 steps. Step 1, replace f by f f of x by y, and then step 2, interchange x and y. And then step 3, solve the equation for y. And then step 4, they replace y by f inverse. And then last step is to check domain range, okay? But normally we don't do the last step. So in step 1, replace f of x by y. So we got this, y is equal to 1/2 times 9 to the x power, and then -3. In step 2, the switch and solve method, I did go over this one when I cover the inverse function in chapter 2. Okay, so just if you forget this one, just look at it. Okay, so then the interchange x and y, so x is equal to 1/2 times 9 to the x y, 9 to the y, okay, -3. Now we solve the that equation for y. So if the either exponential function or log functions, to solve the equation, then you have to isolate exponential term or log term. Okay, so in this case, I'm gonna isolate the exponential term, 9 to the y's power. So I'm gonna add 3 and then multiply 2. Okay, then we got this x plus 3 okay, and times 2 is equal to 9 to the y's power. And in step 4, let's see, we gonna what express y in terms of log, okay, because y is the exponent, right? So we can figure out the actual value of y using the log term, right? This is log of 2 times x plus 3, but 2 times x plus 3 is actually 2x plus 6, right? But anyway, so okay, I mean, this is y is equal to log of what? 2x plus 6 to the base 9. Okay, so now this step, so now what? It's not step 4. Okay, this is step 3, and then step 4, we replace y by f inverse. Okay, f inverse is equal to log of 2x plus 6 to the base 9. Okay, so you want this. So now that's the I solved the, I think 5 problems, right? So maybe 4. I think 4 problems in 4.2. So let's move to the 4.1. Okay, so give me a second. All right, let's take a look at the online homework 4.1 and number 8. Okay, so here's a question. Use transformation to help graph the function y is negative 10 to the negative x. Identify the domain, range, and horizontal asymptote. Determine whether the function is increasing or decreasing. So so we're gonna start from the see that since the problem asks you to figure out the graph of the function y using transformations, so we're gonna start from the function y is 10 to the x power. Okay, yeah, I know we can yeah, we can directly figure out the graph of this y, but let's follow the directions, okay, the problem. So see here. All right, so let's say f of x is defined by 10 to the x power, okay, and then g of x is, let's say g of x is the function given problem, okay, negative 10 to the negative x power, okay. So now the graph of f of x is going to be this. Since the theta base is greater than 10, so graph must be like this. Okay, so graph, this is graph of f of x. Okay, so it's going to be 0.1. Okay, so now what are you going to do? So first we're going to do, let's see, we're going to do reflection about x-axis and then y-axis. Okay, first one is the negative x, right? To get the negative x from f of x, we have to replace x by negative x, right? So f of negative x is going to be the 10 to the negative x power, right? From here to here. That's a reflection, okay? About the not x-axis, but y-axis. Okay. So let me review what in the transformations and the reflections. This is this graph of f of x. Reflection about the x-axis, we got this, and then the f of x will be changed to negative f of x. Reflection about the y-axis, we got this, and then the function will be changed to f of negative x. Okay, so replacing x by negative x, that means in transformation. That means reflection about the y-axis k minus. So I'm gonna reflect about the graph in the y-axis. Okay, so we're gonna get this like this. Okay, so this is graph of f of negative x. Okay, and now then, see, we need to get the negative sign, right, in front of function g of f of negative x. It means this is a reflection. I mean, think about this. To get the negative sign in here, we need to multiply f of negative x by negative 1, which is negative f of negative x, which is negative 10 to negative 10 to negative x power, right? So this is a reflection about x-axis, okay? So I'll just reflect the graph of f of negative x about the x-axis. So we're going to get this. Okay, so that's the graph of negative f of x, negative f of negative x, which is what? Negative 10 to negative x. So this is exactly same as the definition of graph function g of x. Okay, so anyway, so but okay, so the let's see, yeah, so and then what happened to the the y-intercept? It's going to be 0 comma negative 1, right? Okay, all right, so now let's move to the other problems. Okay, let's see, give me a second. All right, so let's see. I think, yeah, so let's move to the problem, homework set 3.2, because 4.1, most of the problems is, I believe you can the solve those problems. I couldn't find out some kind of, change problems or difficult problems. So I think you can get them. Okay, so let's see. I want to cover the problems in homework set 3.2. So the problem number 11, look at this. Find all of the real and imaginary zeros of the polynomial functions. So actually that was the goal of this section 3.2. So 3.2, we're gonna we deal with the polynomial function, and then we want to find out all of zeros. Okay, so now how can you figure out that? So we need to find a possible step. Yeah, I'll just give me a second. Back to here. Okay, so we need to figure out the possible version of zeros. Okay, so let me copy the problems. Okay, so this is problem number 11, 3.2. Okay, so y is defined by 15 x cubed, the minus 61 x squared, and then plus 199 x minus 13. Okay, so what you're gonna do, we need to figure out the possible version of zeros. Okay, step 1. So what does then possible ratio of zeros? Possible ratio of zeros are the ratio numbers, and then it probably it is one of them. I mean, they are possibly zeros. Maybe not. Okay, we don't know yet, but it's kind of candidate of zeros. Okay, so how can you find the possible ratio of zeros? This is the what? Plus minus. Okay, the set. This is set notation. Okay, the factors of constant term. Okay, over factors of a leading coefficient, which is a COEFF. It means leading coefficient. Okay, keep in mind this. So now let me see. You see that? All right. So let's figure out the constant term. Okay, so which is -13, right? I mean, yeah, we don't have to consider the negative sign because eventually we're going to put the plus minus sign. Okay. So factors. Let's figure out factors of constant term and the factors of leading coefficient for each. That's going to be 1 and 13 because number 13 is a prime number. Okay, so since the 13 is a prime number, so 1 and 13 are only what? Factors of 13. So the factors of leading coefficient is what? 1 and 3 and 5 and 15, right? Okay. So what are you going to do? Yeah, so then the possible range zeros, okay, that's going to be what? Plus minus. Okay, plus minus 1 over 1 and the 1 over 3. You see that 1 over 1, the 1 over 3, and the 1 over 5, and the 1 over 15, right? And then 13 over 1, 13 over 3, and 13 over 5, and then 13 over 15. Plus my sign here. Okay, let's see. All right. So and then we need to figure out the then we step 2 is the find um, a true zero, true rational zero. Okay, so there means a rational zero here. See that rational means that all. See, you can see that all numbers what are rational number. That's why it's called the rational possible rational zeros. And then we're gonna find out true rational zero from the set of possible rational zeros. Okay, because the based on the theory of possible rational zeros, one of them, maybe two of them, or yeah, in general, some of them must be actual zeros, true zeros, I mean. Okay. We want to find out one of them. How can you find out? Yeah, there is no uh, the easy way. We just manually we need to plug in each number: +1, -1, +1/3, -1/3, +1/5, -1/5 through the +1 13 over 15 -13 over 15 into the equation, into the function, to see output is 0. Okay, so then but luckily when you look at the answers in the problem, the 1 over 15 plus 1 over 15 or -15 are included only. So I show you. So now let's see. Okay, so you can see that for A, B, C, D, 1 of -1/5 or positive, +1/5 are involved only, right? So all the numbers, I mean, except for D, all the numbers are just immediate numbers. So I think 1 over 15 or -1 over 15, one of them should be extra 0. Okay, so let's figure out that. So using the calculator, okay. So as you can see that I typed the equations with x equals 1/15. So the output is 0. It means that y value is 0. So it means that when x is 1/15, its corresponding y coordinate is 0 under that function. Okay, it means the 1/15 must be zeros. Okay, so x is equal to 1/15 is 0, is a true. Okay, true 0. Now step 3, what are you going to do? Now we're going to, you see, by using the factor theorems, it means this. We're going to look at this one, that polynomial, as a dividend, okay? Then we could express that dividend in terms of the quotient, and then divisor and remainder, which is x minus 1/15, okay? And the quotient and the remainder are, okay? But look at this. So x equals 1/15 is a true 0, means that when you divide the polynomial by x minus 15, remainder must be 0, because when you plug in 15 into x, 1 over 15 into x, then what? 1 over 15 minus 150 is 0, right? Okay, and then when you plug in 1 over 15 the x in the left hand side, we already verified that what the output is 0, right? So when x equals 1 over 15, left hand side turns out to be 0, and then what? Right hand side must be turns out to be 0, because we divide, even though we divide this one into by the x minus 115, so that we express this one as divisor and quotient and the remainder, the output must be on the right hand side must be 0, and x is 1 over 15, x minus 1 over 15 minus 1 over 15 is 0, times whatever is 0, the remainder must be 0 to get 0 as output. Okay? So remainder is 0. So now I'm going to figure out q of x, okay? Using the synthetic division or ordinary division. But let me use the synthetic division, okay? So we're going to figure out q of x, and then we're going to find the possible rational zeros. And then repeat, pretty much we repeat step 1, 2, 3 for q of x. Okay. So, but so let me keep going. Okay. So now then, step 4, see, we find step 3 is to find q of x. Okay. So using synthetic division. So just write down here, and then so 15, negative 61, and then 199, and then negative 13. Okay. So this is copying down 15, and then 1 over 15 times 15 is 1, right? And then adding them up, negative 60, okay? And this is going to be negative 4, so 195, okay? And then we'll see 13, right? Okay, it's going to be 0. Yeah, it should get 0, because if 1 over 15, 1 over 15 is a 0. So it means that when you divide this polynomial by x minus 115, the remainder must be 0. I told you, okay? All right. So if you don't get 0, that means something you got wrong, okay? So then the q of x is going to be what? 15x squared minus 60x plus 195, okay? Why this x squared? Because I told you that the meaning of this number is what? Coefficient of polynomial 1 less degree than what? Dividend, okay? So in this here, the polynomial is a degree 3 polynomial. So what this? Now, fortunately, this is a quadratic polynomial, so we don't have to do we don't have to repeat step 1, 2, 3. Okay, so because we know how to find out zeros, just apply the quadratic formula. Okay, so I'm gonna here apply the quadratic formula. Okay, negative b plus minus square root b squared minus 4ac over 2a. Okay, so what is a b? B is negative 60, right? So we got 60 plus minus square root 3,600, right? Because 60 times 60 is a negative 6 times a negative 60 is 3,600, right? So 3,600. So and then plus a minus 4 times 15 times 195. Okay. Then divide by 2a is 30. Okay. So then let me use a calculator. Okay. To figure out the quantity on the square root. Right, so this is 3,600, okay, minus 4 times 15 times 195, okay, which is negative 8 81, negative 8 on 100. Okay, so this is a 60 plus minus square root of negative 8 100, which is the 90 square, right? So that is equal. Let me just divide. Okay, divide into two fractions. This is just 60 over 30 plus minus. Then 8,100 is what, 90 square. So we got this 90i. Okay, because 8,100 is what, 90 square. So square root of the negative 81. This is equal to square root 8,100 times square root negative 1. But square root negative 1 is what? That's a complex unit, I. And this is a 90 times I. Okay. So I over 30. So which is what? 2 plus minus. This 30. Okay. And then 3i. Okay. So the answer is C. Okay. So we got. So now we could express now here. So the equation 15x cubed minus 61x squared plus 199x minus 13 can be expressed as x minus 15, 115 times q of x can be expressed as what? X minus, use this one, 2 plus 3i times x minus 2 minus 3i. Like this. So when x is 115, that's going to be 0. When x is 2 plus 3i, 0. And then when you plug in 2 minus 3i into x, it's going to be 0. Okay. The polynomial returns 0. Okay. So we completely factored that polynomial as product of the binomials. Okay. So anyway, so this is how to find out all of the real and immediate zeros. Okay, keep in mind this. So the I'm going to continue. Yeah. We'll cover the problems for exam 3. Okay. So next time.